go through some safety, welcome and safety thing. Okay. Our host from CMD.
So, thank you very much for coming tonight. Apologies for the AV interruptions. It's a new setup. I haven't used it before. I still haven't because we went with this. So, on a health note, please avoid the cables here. That's not for walking over. Also, wall on the side, you see it's cornered off. That's because there's work going on in that area where the office is getting extended. If you need to use the toilet, it's through the doors at the end to the right. All easy. Also, of course, the usual spiel. Yes, we're hiring, hence the extension of the office. If you want to do cool stuff with AWS, come join CMD. You probably saw this whole bunch of brands on the door when you came in. If you didn't see, all the stickers, the all names for companies, brands within the Mentor Group. They all do different things. A lot of them do serverless related stuff. If you're not interested in AWS, but do want to do things with serverless, either as an app developer or other clouds that I'm contractually not allowed to mention. It's not true. I just don't like to. Because as well. Otherwise, hope you enjoy the evening, and I'll
just do an acknowledgement of country. Our meetup is being held on the lands of the Wurundjeri people of the Kulin Nation, and I wish to acknowledge them as traditional owners. I'd also like to pay my respects to their elders past and present, and Aboriginal elders of other communities. So we've got Pete today. We're lucky to have him, a mainstay of serverless. His experience to share, and so that will be good.
Thank you very much. I hope you can all hear me at the back. I can see you all, which is good. Thanks for coming in this terrible weather. My name is Sbarski, and I will talk to you about my adventures with serverless. Now, can I get just your hands up? Who has used Lambda or done things with serverless architectures? Okay, and some people haven't, right? That's right. Okay, so this is going to be very exciting. I titled my talk Dancing with Serverless because I thought that it was going to be just like George Martin's Dance with Dragons, but maybe fewer dragons and more Lambda functions. Okay, let's see. So I tried this joke again a month ago at Aryan's AWS user group, and I got the same response. Nobody laughed, and I was like, damn, doing this in front of the mirror at home is so much easier than doing it live in public. So also, I'm going to apologize to Aryan right now because this is the second time he's going to hear this talk. So he's going to be like rolling his eyes at all the lame jokes that I'm about to make. So I'm sorry. Forgive me, please. So as I mentioned, this is me. I am this guy. I am an AWS serverless hero, which basically means that I talk about serverless and AWS a little bit too much. I wrote a book called Serverless Architectures on AWS. Here are some covers. I was actually very lucky to have had the first edition of the book translated to Japanese and Mandarin Chinese. I don't speak those languages, so if you do and pick up a copy, let me know if it's good. I don't know what it says. I mean, hopefully it says what I said. Who knows? Could say something else entirely. I helped to organize this wonderful meetup with Matt, so come back again next time, please. I previously worked for a wonderful company called A Cloud Guru. It has now been acquired by Pluralsight, but previously I was VP of Content, and then I was VP of Education and Research. And I'll talk about a little bit about my journey and what A Cloud Guru did as well. Used to organize a conference called ServerlessConf. You may guess that it was about serverless, and you'd be correct. And now I'm building something new, and I will talk about that later as well, keeping you all in suspense. we'll see if the pizza comes before I talk about it first. Oh yeah, by the way, this is the second edition of the book that I wrote. It's out, have a look. It's actually a photo of Jeff Barr. He's the chief evangelist at AWS, holding a copy. Look, I don't know if he has read the book, but he's got a copy at least, so it's real. I saw that photo and I felt, I have made it. This is it. I feel like I peaked at that moment in my life. So yeah, if Jeff is watching this in replay later, I hope you like the book, Jeff. So when I started thinking about this talk and what I can talk to you about, I kind of decided to of my experiences with serverless. And let's make it interactive. If you have questions, put your hand up. I'll happily answer questions. If I cannot answer them, I'll pretend something and, try to get away. I will say a few things that are controversial and, may go against. Welcome. For those who are watching this later on YouTube, we had some people enter the auditorium. Wonderful to have more people here. So I was saying that I will say some controversial things that go against kind of conventional opinion. So that's my opinion. Please let me know what you think. I want to be open and transparent with you. And by the way, this image is I was trying to use DALL-E to create a picture of me thinking about cloud computing. So this is apparently me, according to DALL-E. Maybe if I was with a little less hair and a mustache, I would look like this guy. That's what DALL-E thought. That's how I look.
It is November.
It is, yes, yeah.
Just saying.
It is it is November. That's true. So I mentioned that I previously used for a little company called A Cloud Guru, and A Cloud Guru was kind of famous in that it created and distributed online video courses. And it was primarily a serverless company. So it was started in 2015 by Sam and Ryan Grunenberg. Ryan created content, Sam created the serverless platform. And Sam built the original platform in just 4 weeks. And the reason why he did it so quickly was because he was on holidays. He only had 4 weeks. He was with his family in Tassie. And he was like, okay, I need to build something quickly because my brother is creating this awesome content. Let's put it up online. And so the initial platform that he built, and I worked with him, I was his friend, so I saw it happen right in front of my very own eyes. That initial platform was very impressive. You could watch videos, you could do quizzes, you could buy courses. It kind of had all the expected bells and whistles that good e-commerce platforms have. And because it was just the two of them initially, just Sam and Ryan, I joined, as I like to say, as the first full-time employee in 2016, February. Thank you very much. It needed to have a low operational overhead, and scaling was interesting. I remember, so it was all serverless, it was all running in Lambda. I remember Black Friday, 2016. We were actually at reInvent. And I think we did something like 40 times the amount of sales that we would do on any other day. 40 times. And the platform just scaled wonderfully. We didn't have to do anything, provision any new infrastructure. We kind of just sat there and watched as kind of sales came in and we're like, wow, that's kind of cool. It was really like magic. And like I said, it was all serverless, it was service-full. Welcome to Dawn. She just entered the auditorium. Now, Dawn was at the AWS user group meetup as well last month, so she has also heard this talk. And I don't know why she's back, because she's going to hear exact same thing again. And Dawn, I already apologized to Aryan for the same jokes, and I apologize to you. But the platform was serverless, and it was service-full, meaning that we were using a number of third-party services, like Auth 0 for authentication, Stripe for payment processing, to avoid rebuilding some of the common functionality. We didn't want to do that undifferentiated heavy lifting. And so this was kind of this initial diagram, this initial architecture that was born in 2015. So we had a website. It was built in original AngularJS. Is anybody old enough to remember AngularJS 1.0? Oh my god, you poor people. We'll talk later. Scary stuff. So we had that SPA built in Angular. Users would authenticate in Auth 0. protected actions like purchasing a horse were performed in Lambdas, which were fronted by an API gateway. The database that we used was Firebase, and increasingly enough, Firebase can communicate directly with the front end using WebSockets. So it doesn't need to go back out via Lambda and API gateway to return a response, right? You just open a connection, you open the website, it opens a connection to Firebase, and the database basically can send messages straight to what you're seeing, straight to the website. So any changes made to the database would basically semi-magically appear in the user interface. Our video files, our videos were stored in S3, that's normal. But you may notice something interesting about this architecture. It is actually a serverless monolith, right? There's one database, Firebase. There's a bunch of functions kind of writing to that database. The front end is also coupled to the database, so it's a monolith. But you know what I say? Like, this was okay. It worked. It scaled well enough for our size at that time. It got us to market very quickly, and it worked well. So, fine, monolith. So as we grew, we realized that we needed to evolve our architecture. So around 2017, 2018, we decided to move to a more microservices style architecture because everybody loves microservices. Now, really, the reason for that was our team structure. Kind of as we were growing and bringing on more full-time development teams, the architecture had to grow with it too, right? And moving to microservices allowed us to achieve that acceleration with highly focused teams who would be responsible for each particular part of the application. So we had a team accountable for the student experience, a team accountable for exam taking, a team accountable for e-commerce, and so on. And as you can see in this diagram, we moved to a GraphQL-based approach, where we had a GraphQL library hosted in a Lambda function behind an API gateway, as before. And this endpoint could query multiple microservices, which were really just collections of Lambdas with their own DynamoDB table. That GraphQL endpoint would use schema stitching to create responses for the client, and it would talk to multiple microservices, stitch together a response, and send it back. And now, an interesting element of this architecture, though, is that we were still using Firebase, and we also began using Algolia for search. And if you're not familiar with what Algolia is, it's basically hosted search as a service product, right? So you can dump some data into it and then you can search. And we used DynamoDB streams to capture events and intelligently update Firebase and Algolia just as we needed. So we could still maintain that great user experience and kind of migrate slowly, thoughtfully, without having to do an entire database migration upfront. You can actually think of that Firebase database there as a materialized view of our DynamoDB databases, which powered our user interface. And by the way, I also told this story at the AWS Meetup. I tried to use Amazon Cloud Search. I don't know if anybody's even heard of that service, Cloud Search. I really tried, instead of Algolia, and it was terrible. So obviously, AWS gave up on that service a long time ago. So don't waste your time.
It's still there.
It's still there. You can still run it, but why would you?
They really turn them off.
Yeah, they never turn them off. So just use Algolia if you want search. Don't use Cloud Search. Yeah. Oh, SimpleDB. Yeah, that's still alive, right?
Barely.
Barely. Well,
Barely.
so wow.
They're really trying to get rid of it.
Can you imagine? So, and think about this. We kind of went from this monolithic architecture that I showed you 2 slides ago to microservices without having to think about the infrastructure, right? We didn't need to think about server provisioning or web farms or load balances. And once we re-architected our system, we kind of did it just step by step, simply by changing a YAML file and redeploying. And what I like to do is actually show what was happening to our system at that time and what we paid for it. So this is around, I think, July of 2018. So I've got this data, I'm no longer employed, so surely it's fine to share. Nothing bad could possibly happen. Yeah, it's fine, I'm sure. So this is July 2018. We had 289 Lambda functions grouped in different microservices. Well, 19 microservices. 3.7 terabytes of data stored in S3. We did 107 million Lambda invocations in that month and 45 million API requests through the API gateway. We had an egress of 3.8 terabytes of data going out to our users. So this is basically users streaming video from S3. And we had 650,000 users at that stage. And this was our build. Ta-da! Wonderful. It's interesting that, remember, this is July of 2018, and we know that AWS doesn't really raise prices. So, our bill today for that amount of usage could actually be even lower. And you can see that mostly it's the bandwidth, right? It's the cloud front that's costing money, not even compute, Lambda, or API gateway. So, not that much. Another interesting note is that I think for the first 2 years of the life of our company, we actually paid nothing for compute and API. We were entirely within the free tier that AWS provides. And because we had virtually no infrastructure cost, that really helped the business succeed, right? So now let's move forward maybe another year and a half. We kind of kept evolving our architecture forward. Our teams added to service discovery. So now that GraphQL endpoint could actually figure out which microservices to query depending on the request. And things kind of became even less coupled because of that. And I should mention that that service discovery mechanism was built in-house because I think our team was doing it before CloudMap came out. So CloudMap, it's another AWS service that is service discovery, it does service discovery. So I cannot speak for the company now, but maybe if they were building this architecture now, they would look at AWS CloudMap instead of building it themselves, possibly. Matters like quickly, please watch, because I'm rambling on. I mentioned that, so we used Firebase as the database, remember? And it could connect via WebSocket straight to the client, and whenever a change was made, it could push things out straight to the website, so the user could immediately see the result. And I've had people ask me, Peter, if you get rid of Firebase and you just use DynamoDB, how could you achieve the same beautiful user experience, right? Something updates in DynamoDB and then it magically appears in the front end. And DynamoDB doesn't have WebSockets built in, right? And it cannot stream data to clients. However, API Gateway does have WebSockets. So here's something that we can actually do using API Gateway. So at a high level, we can kind of recreate this functionality like this. First, you create an API Gateway with a WebSocket. Whenever a connection is made, you receive an ID that you can store in your own separate DynamoDB table. And then when you need to send data back to the client, you look up the connection ID and invoke the appropriate callback to the API Gateway. And the API Gateway sends the data back to the client via the open WebSocket. So at a high level, you can kind of create your own WebSocket mechanism. And a few slides down, we can actually have a look at a full kind of like end-to-end implementation where we recreate Firebase, but with DynamoDB end-to-end. Amazing. Oh yeah, now we're getting to my favorite slide, this guy. As I was kind of putting together the previous slide about WebSockets, it reminded me of something called Monolith architecture. Does anybody know what Monolith architectures are? No, except for Don and Arya, who already obviously heard this stuff before. They're not allowed to answer. So Tim Wagner, the creator of AWS Lambda, he introduced me to this concept. So it actually comes from real estate. In real estate, a Monolith architecture is a building that is traditional on the front, classical or traditional, but it's modern on the back. And usually it's done to kind of conform to a neighborhood regulation, for example, that you cannot change kind of the way the building looks on the street. And a monolith architecture in software is very similar, right? So it would have a conventional approach on the front, but a more modern, say, serverless approach on the inside. And serverless Monolith architectures like WebSockets are stateful on the front, but function-based on the rear or on the implementation side. And then, of course, you can take this tortured metaphor and reverse it. You can talk about reverse Monolith patterns, right? Where you have serverless functions that talk to more conventional, standard, traditional systems.
Is it still Monolith?
So, reverse Monolith. And then you can torture this argument, you can torture this idea even further. You can have a double Monolith, right? Double Monolith occurs when you have like a super old system talking to another old system, but the way they talk, like the implementation, is done in a more modern way, right? Serverless. So imagine maybe an old 1980s system needs to talk to another old system, and it's all, I don't know, XML. You can still build the implementation, kind of the way data is transitioned between the two, with a more modern approach. Yes, Matt?
Is that the same as the Strangler pattern?
No, Strangler pattern is a little bit different. Strangler pattern refers to the idea is that you can kind of take bits of existing functionality and re-implement it with a more modern approach. So yeah, I guess you can apply this idea as well. Yeah, you're right. But yeah, like I said before, the WebSockets, stateful on the front, stateless on the back. WebSockets with Lambda, that's an example of a Monolith architecture. So now tomorrow when you are at work, you can just throw it at somebody and say, hey, I'm thinking of doing this as a Monolith architecture, what do you think? You just look at the face and see what they say. Trust me, it works. So my experience, working at a cloud guru, writing the book, talking to brilliant people such as yourself, has really helped me to understand some of the benefits, but also challenges of working with serverless systems. And a lot of the benefits can be summarized like this, and I'm probably going to miss a couple. So, going serverless and using services to avoid doing that undifferentiated heavy lifting definitely makes you faster, right? And I have felt this myself, and I don't think I can go back. The scaling that you get from Lambda and other services is incredible. Initially, it can be cheap or free, but you obviously also have to be very careful. You have to understand what you are buying. If you have intermittent choppy usage, yeah, perfect. Lambda API Gateway can be perfect for you. If you have a need for sustained, ongoing compute, then maybe Lambda isn't the right thing for you. You have to look at other options as well. When starting out, you also have to be careful, right? Because you can blow your foot off. Most trivial example that I've done a bunch of times is what I call serverless cancer. So serverless cancer occurs when you put, let's say, a file into an S3 bucket, and then you have a function respond to that file, respond to that event, and then write another file into the same S3 bucket, which causes another function to run, which creates another file, and it just goes like this in a loop. Now, what's worse is that, unfortunately, once I made the function create two files. And what happens then is that you get this exponential explosion of functions running, creating more files, running again, until I get to see my bill and I cry and I beg AWS support to please forgive me because I will never ever do that again. I'm actually going to show you an implementation of my serverless video processing application. And I did that exact same thing accidentally, writing into the same bucket, and it was a mess. All I want to say is Lambda is a supercomputer, right? It's incredibly powerful, but you do need to be just a little bit careful, especially if you're just starting out. And by the way, this mistake that I did, I was like 2 years in, and I thought, oh man, I'm such a pro, I'm so good, and then it was terrible. Serverless can be operationally efficient, so obviously you don't have to think about patching virtual machines or deploying new clusters. In that way, it's amazing. But it isn't free of operational concerns. You still need to know what to do when things slow down, right? You still need to have a way to robustly deploy your applications, to make changes to your database. If something goes wrong, your customers are not going to care that it's the fault of AWS, right? They're not going to know about S3, hey, it went down in US East 1, nothing's working, half the internet is down. They are going to blame you, right? So you need to think about resilience and recovery, how do you escalate issues to AWS when things go bad? Or how do you escalate an issue to a third-party service provider if you're using somebody else? A great benefit is that it's not Kubernetes. This one usually gets the biggest laugh, but it's true. It isn't Kubernetes. And another one is that I think that in a lot of cases, large architectural pivots are possible. Again, they are not going to be free or easy, but at least you don't have to think about how many virtual machines you need to provision, how to get them up and running, whether you patch the OS. You just think about the architecture and the code. And for me, personally, that's more than enough already. And I think finally, the one that's really underestimated is that developers really, really love the serverless approach. They love using Lambda, they love using AWS. The feedback loop is so short. So if you want to attract people to your company, think about this. I think it's a big benefit that isn't talked about a lot. Also, a bonus hint, don't go looking for serverless developers with 10 years of experience. You will not find them. They do not exist, at least in this reality, in 2022. So look for developers who are enthusiastic about technology and learning. And they will pick it up, and they will run with it, and they will create magic, just like all of you do every day. I'll do one more slide, and then, I don't know, we can break for pizza, or we can continue, because the excitement is about to begin. But I'll talk about some common complaints as well. I think those who have used Lambda, AWS, can really relate to this one. I think the number one complaint is that it's just hard to develop and debug. And I understand this, because for many years, a typical development process has been, you write a function, you deploy it to AWS, you test it, you see what happens. Maybe you write some unit tests, maybe you mock some inputs, try to run the function locally on your computer. Integration tests are harder because you may have to mock multiple AWS services, use Cloud Stack. Really, because the cloud is involved, there's this bit of write, deploy, wait, test frustration, and it really isn't the best. Now, I have an answer for this in a little while that I'll share with you. Things can be tricky to observe and monitor. This is really true for any distributed system. This isn't the fault of functions on Lambda. Once you have hundreds of functions, millions of invocations, or if you have hundreds of containers, it doesn't matter. Things become hard. And Amazon CloudWatch is not the greatest service for helping you understand what's going on. And I said this line, I think I was in Perth, and there were a bunch of AWS people there, a bunch of AWS developer advocates. And I felt so bad saying it, that CloudWatch wasn't the best. Oh. I just saw the faces and I felt terrible. But look, it's true. And I've had, those who have experienced it know what I'm talking about. Some tasks are very hard or impossible to implement with a serverless approach. Can you convert a 2-hour video in a Lambda function? Or download a file from an old SFTP server? For those who are my age and remember what FTP is. Functions are ephemeral. They will last for 15 minutes. API Gateway has a 30-second timeout. Other services have other limitations. And of course, people are still worried about locking. I don't actually think that it's a major problem that people need to worry about. Are you really going to be moving your application from one cloud provider to another, or even going back on-prem? Yes.
It's just one API call away.
One API call away. Look, all I'm saying is, if you are moving from AWS to on-prem, you have probably become Dropbox. So congratulations on that. It's a great success story. So now I really want to get into a little story of what I'm building today and how I am solving those challenges that I just outlined myself. However, I have a question. Should we break for a little pizza first, or should we continue? What do you all think? I know pizza's day, it's getting cold, so 15 minutes? Do people want a little break before we get to the actual goodness, or there's so much stuff coming up? Yeah, I think we need to be powered up, right? Let's 15-minute break, let's do it, and then we'll come back.
You're on.
I'm on?
Yep.
All right. All right. I hope the pizza was good. I'm sure people watching this online were thinking, oh man, I didn't get any pizza. So this is why it's worth coming to this meetup. Now you know. So I'm going to tell you about how I'm thinking and solving the challenges that I outlined today. So, like I said, I left ACG earlier this year after it was acquired by Pluralsight. I thought it was a good time to go. I had a bit of a break and my hands started getting itchy. I wanted to build something again. So, the rule that I set for myself was that whatever I did had to be serverless. And I think that made a lot of decisions for me a lot easier. Obviously, I had to be fast and reduce my operational overheads to zero. It's just me working on my own. Given what I'm planning, I could potentially need a lot of computing power, computing and processing power down the road. I wanted to leverage as many AWS services as possible. Like, I don't want to rebuild things again. If certain problems have been solved, I just want to use the solution. I want to focus on what makes my product, my idea, unique. And of course, I wanted to have local dev and debugging be as simple as possible. So, codename, by the way, I decided to build a wealth management system. So I wanted a system to help me track my money, budget, review transactions, give me insights into my spending habits, help me plan for the future, visualize my goals, track things like insurance, receipts, help me do taxation, so quite ambitious. And I should mention that these screenshots do not look as lovely as I want them to be. I'm working on that. I'm working with a talented designer who is amazing, and he's hopefully going to make it look beautiful. Look, obviously, whether this succeeds or not, depends on whether I can work out the business model. What does it look like? I don't know yet. But I think the tech is very cool, so I want to talk to you about the tech itself. Also, if there are any volunteers interested in something like this, please, if you want to get involved, help me test it, give me feedback, work with me. Just go to the URL, type in your email, and I'll contact you, and we'll have a fun time. So, to help with the implementation, I decided to use the Serverless Stack framework. Has anybody used this framework? Okay, excellent, a couple of people. So there are various frameworks to help you kind of organize, deploy, build your serverless applications. There is the serverless framework, there's SAM, Chalice, there's a whole bunch. So I use this one. Now, SST, Serverless Stack Framework, has a few really great features, including the ability to work on your Lambda functions locally, live, without walking or redeploying your app, and I'll show you what that means in a moment. You get a handy console to view and manage your resources. That is a lot quicker than the AWS console. And you get additional composable constructs on top of CDK, on which SST is based. So if you're not familiar with CDK, it stands for Cloud Development Kit, and it's really just a way to define your infrastructure in code. You use a regular programming language like JavaScript or Java or C# or Go, and regular programming constructs like conditions and loops, and you can define your infrastructure, create unit tests if you want. So SST builds on top of CDK and provides those additional constructs to make development of serverless apps even easier. So as an overview, here's what you get. Local dev and debugging. It's built on top of CDK, as I said. You get the console, you can see like a little snippet on the side. You get higher constructs like function and config. So you write even less code. And you get interesting features like Auth. So Auth is actually a brand new feature. It was introduced like a month ago, and I find it fascinating. So here is what Auth does. So I currently use a service called UserFront for authentication, right? Typical authentication service, you go in, you can register, sign up, you create your password, then you can log in with your password. It's very similar to Auth0 or Cognito, if you're familiar with those services. It's good. UserFront is more friendly than Cognito. It's cheaper than Auth0. But here is what SST can do for you. So it can deploy a few Lambda functions and API routes to handle authentication flows. It basically creates your own serverless and free authentication provider. It allows your users to authenticate via third-party social providers like Google or Twitter, or you can couple it with your email or SMS sender to send emails or SMS messages, with a magic link, so your users can authenticate through a link, just like, say, Slack does it. And once the user goes to the social provider or clicks on your link, they are provisioned with a JWT token, which is then used to authenticate all further sessions in your Lambda code like normal. So the entire library is stateless. All mechanisms are handled through those short-lived JWT tokens. And in a nutshell, you get this free, passwordless authentication system running entirely in Lambda, fully under your control. You can extend it to support multi-tenant SSO configurations if you want, no problem. You can keep claims or information about the user in your own database, so each time they log in, you can look the user up. But the cool thing is that you don't need to store or manage passwords. You don't need to create password reset or password forgot functionality. And that's kind of cool, because I think, companies like Google and Apple are now training our users that passwordless future is not only possible, but that it is preferred, that we're going into this passwordless world. So this kind of interesting capability is free, and SST is an open source library, so you can have a look at what it does, how it deploys those functions, how it all works. Oh yeah, I think at the moment it supports any OAuth 2 compatible services, any OpenID compatible services, and it has SST has authentication providers for Google, GitHub, and Twitch. Yeah, and of course, you can generate your magic links if you want. So there you go. Cool. But my favorite feature is that of live Lambda development. So SST allows you to debug and test Lambda functions locally while they are being invoked remotely by AWS. And the way it works is that SST proxies all the requests from AWS to your local machine, functions on your machine run, and then the response is proxied back to AWS. And you don't need to mock any AWS services that your Lambda functions use. You don't need to use local stack or anything like that. You don't need to redeploy your functions to test changes. So what SST does is that it deploys little stub Lambdas into AWS. They open a connection via WebSockets to your computer. This is all done seamlessly. You don't even know about it. And so whenever AWS invokes one of your functions, the little stub function in AWS proxies the request to your machine. Your code is run locally, and then the response is proxied back. There's a DynamoDB table that keeps a log of connections. There's even an S3 bucket that is used to, as a temporary storage for request-response messages if they are too big. But it's all handled for you automatically, transparently. You don't even know about it. As far as we see as developers, is that you kind of deploy your application once, then everything runs, code executes locally on your computer. You can put a debug statement. If you use VS Code, you can put a debug statement. You can walk through your code line by line, just as we've been doing for decades before this. And in practice, this works very well. I can work in functions locally, save them. I only need to deploy just once to create that little stub, and then I just work on my code locally without ever redeploying. It's amazing. Obviously, functions executing on your computer is a little bit different to have them running in Lambda. For one, you have more CPU, you have more memory. But if you're working on your code, if you're working on your logic, then it doesn't really matter, right? The experience that you get locally is amazing. Being able to save, put breakpoints, step through your code. I love it, and I don't think I can go back to what we used to do with serverless before. I think this is the way forward.
Here's a question
Yes.
for you.
Yep.
How does it handle date formatting?
Date formatting.
Yeah, because I've done some stuff with other tools where it takes your machine's date
Yep.
culture settings,
Yep.
but they could be different when you deploy in AWS.
Yeah, I mean, look, this is really just kind of like a dumb proxy. So all it does is that it just proxies request response messages. Obviously, when you go to production, right, you deploy everything to AWS and it runs in AWS as you would expect. So there isn't, it's kind of special, it's amazing when it works, when you see it, but it's not really anything amazing behind the scenes. Oh yeah, one thing that does happen actually, Bill, is that if you use this for too long, sometimes the authentication token can expire as well. And then you get an error message and you have to kind of rerun SST again. Yeah.
Does that mean that the deploy cycle is very fast if you just update it from Meetup?
Absolutely. It's instant. It's absolutely instant. You just hit Command S and it's done. Until then you go to production. Obviously, when you go to production, you have to redeploy the entire thing. So that was kind of like local dev and debugging. I hope I blew somebody's mind here in the audience. Excellent. So what about observability and just knowing what's happening in your system? Obviously, you can and should use CloudWatch and X-Ray. They are built in. They are okay. I think a lot of us have had experience using those tools. Not the easiest. You should find me from being AWS hero for saying that. But another tool that I use is Lumigo. So this is a paid product. It's not free or open source like SSC. You have to pay for this. But I use it, people ask me about it, it's nice, it hooks into your environment, it pulls data from it, and it actually presents you kind of like with nice, actionable insights. When things fail, like your Lambda function fails, you get a nice email. The way the issues are grouped is kind of nicer than CloudWatch. And I think the main advantage to me is that Lumigo helps you find things quicker. I think they have a free plan, there's also a paid plan. Not affiliated with Lumigo in any way, just showing you because people ask me about it. So, back to my Fatfire application. So, my product is made out of a number of services. I have a core service, I have an exchange service, which does a currency exchange, and soon it will be replaced with a different SaaS. I have a history service that keeps daily history of your balances and changes to your portfolio. I have a cleanup service which destroys all data, and an analytics service which creates nice looking beautiful graphs, an integration service. So this talks to other third-party services that I use, like Plaid. So Plaid, it's a popular service for integrating with your bank account, for example. Insurance service for handling insurance, receipts, and tax. And I'm not going to lie to you and say that I have this beautiful, beautiful microservices architecture that follows best practice. And for now, while I'm still figuring out the business model for the application, I have made certain technical concessions up front. And here is an example. So I have allowed certain Lambda functions in one service, in one microservice, to read and write directly to a database that belongs to a different service, like that. So normally, this is a big no-no in microservices architecture, right? Because this is coupling, right? If I make a change to the database, now I have to update all possible functions that could be using the database across all possible services. I'm breaking all of the contracts. So what I have created here, effectively, is I built a serverless monolith again. I have defined my services, but because I have allowed functions, certain functions, to cross boundaries, I've created a monolith rather than having cleanly isolated microservices. Not a great idea. So how would I fix that? I mean, this diagram kind of spoils it already. I mean, one way is to make sure that everything goes through an interface, right? If a microservice has an interface, which could be, say, fronted by an API gateway, all requests, read and write, go through that interface. And this is akin to having an interface for a class, right? We don't know about the inner workings of a class. Inner workings may change. We don't really care. As long as we adhere to the interface, we're good. Solid approach works nicely in most cases. May have problems sometimes. You may get complications if there's a chain of things that need to be called. There could be latency issues as well. but in many situations that are not overly complex, totally fine. I think there was a question, maybe? No. Now, if you don't need an immediate response, right, and you're fine handling eventual consistency, meaning that things can be updated over a period of time and in a different order, event streaming is very popular. By the way, the YAO conference is coming up in December, and every time I go to YAO, I love the conference, but there's 20 talks on event streaming. For some reason, they just love event streaming. So if you want to learn about event streaming, I'm sure this year's YAO will have a talk about event streaming. So there you go, promotion. So you can use the capability built into DynamoDB to stream all changes, like updates and deletes. And you can have other functions invoke on those messages and then update other databases. So this provides a looser form of coupling, but the nice thing is that you're using the capability and robust nature of DynamoDB and Lambda to do it. So just have your Dynamo stream all the changes and have other functions pick that up and respond to those events. So remember this little architecture for A Cloud Guru that we had, where a GraphQL endpoint could update one of the microservices, then the microservice would stream changes from DynamoDB to a Lambda function that would update Firebase, and then that would update the interface. We can recreate this entire architecture without Firebase entirely, just using DynamoDB. Super simple. So the way to do it, let's just do it quickly without WebSockets. I know I'm running out of time, so I'm going to run through it. Is that you create an API endpoint which writes to a database for a function. Then you have a string. Then you have another function which picks up those events, everything that happens to the database. And then that process, a Lambda function, can create kind of a materialized view based on the events it picks up. Then you can create another read API, and you can get the data. So effectively, you can have kind of like the read API and a write API in your application. So that's kind of like step one. So that's your materialized view right there. So now we're going to add some WebSockets, and we will recreate Firebase ourselves. And if anybody goes and does this and makes $1 billion, please remember where you had it first, because I'll remember you. So here is partially our architecture, right? So from before, we have our materialized view database. All we need to do is create another event stream. We'll create another event stream. Jump back. Have another function which will pick messages up from that event stream. That function can look up connection IDs that we spoke about before from the WebSocket, and then send data back to the client via the WebSocket API. And I'm skipping through a lot of detail because I'm running out of time. I have like a description this long of how it works step by step. So if you're very interested, let me know, and I can read out the description to you after this, only if you're very interested. One word of caution though, if you are using DynamoDB streams and you wish to have multiple consumers, don't attach a bunch of Lambda functions directly, because AWS will throttle you. In fact, AWS clearly states that not more than 2 processes should be reading from the same stream shard at the same time. If you have basically 2 Lambda functions reading from the same stream shard, you will be throttled nearly immediately. So a better approach is to attach one Lambda function to the DynamoDB event stream, receive the event, push it onto an SNS topic, and then you can fan out to as many functions as you want and have those functions deal with that data. So this is a much more scalable way than just having multiple functions attached to the DynamoDB stream. So please use this approach if you don't want to be throttled. Yes?
And also subbing event bridge.
Yes, event bridge. Excellent.
Am I spoiling?
No, well, we just had a mention of event bridge, and that is a great segue. Because you can evolve your event streaming, this is what my notes say, you can evolve your event streaming and event-driven architecture to the next level. So if you haven't looked at event bridge, I strongly suggest you do. We have some Event Bridge fans in the front row here. So Event Bridge is a serverless event bus that is scalable. It supports multiple consumers. It provides at least one delivery semantics, exponential backup for 24 hours. It integrates with a bunch of targets like Lambda. So if you desire even more flexibility, all your events aren't just generated by DynamoDB, Event Bridge is that natural choice. It's a great service for you to look at. Push your events there, have multiple subscribers, multiple Lambda functions hanging off it, and it's really nice and really durable. I'm running out of time a little bit. 5 minutes, excellent. Just quickly, step functions is another great way to help you build distributed applications. So step functions is a service that lets you coordinate microservices and make changes kind of in a robust, traceable way. Step functions basically allows you to define workflows, right? And it's simpler to use than the old Amazon simple workflow service, which, as the joke goes, was anything but simple. You're all too young. It's fine. But
service that I was involved in.
yeah, but you've had this joke before as well, so yeah.
Yeah.
So yeah, I wrote all the jokes down. But it's great for distributed applications. And I think if there's one lesson that I learned, one insight that I have gained, is that step functions is great for workflows inside a microservice, like at a very granular level, and as a way to coordinate microservices at a high level. So it's really nice. I had like this beautiful diagram that goes through step functions workflow in detail, how you can have a sequential flow, and then you can parallelize things and you can handle error states in different ways. But I will skip over it. And then same way you can kind of manage interactions between higher level microservices as well with step functions if you want, and handle error states and retries and backoffs and all kinds of things. Look, basically think of step functions as a full ETL workflow pipeline, but for your services. And in the 3 minutes that I have left, because I have to give Matt a go, a few years ago, I kind of was like, can I use a serverless-only approach to solve a problem that you normally wouldn't solve with a serverless approach? And I was like, can I convert a huge video file from one format to another using Lambda? And normally you wouldn't do it, right? It doesn't make any sense. So I did it. I came up with an approach for it, and I implemented it, and I'll share a link in a little while. And I'm not suggesting that anybody does this. Don't re-encode video files this way. It's terrible. I mean, just use AWS Elemental's Media Convert if that's what you need. But what I want to illustrate to you in the next 30 seconds is the kind of thinking you can apply if a ready-made solution doesn't exist and you are thinking of going with a serverless approach. So this is the divide and conquer approach. So what I did, I took a large video file, then I split it up in parallel into tiny little segments. Then I converted those tiny little segments at the same time in parallel, and then I merged them together. And I did it all using Lambda and using a little utility called the ffmpeg. It's a C library that you can just run in Lambda. And I have this little step functions workflow that actually describes how you can do it in parallel, even for a very large video file. You can get my book and read more about it in detail, plug down, or for free, you can check out that link because that's my blog post, which also describes it. Then you don't need to buy a book, although buy the book. When I implemented the algorithm, my approach, I actually timed it on my MacBook Pro on a traditional EC2 instance, and I had my serverless Lambda approach. And in nearly all cases but one, my serverless Lambda was actually quicker. And it made sense because when you run ffmpeg normally, it converts the file like 1 byte at a time sequentially. But when you use a serverless approach, when you can do things in parallel, you can do it much faster, right? Because you're not doing it sequentially. You can you're using a supercomputer to do things in parallel at a great speed. So anyway, I'm going to wrap up now because I've spoken for too long. But I think there are answers now to a lot of these problems. Local dev and debugging, using SST, observability, using tools like Umigo, some hard or impossible tasks. Yeah, maybe you do have to use containers. Fine, that's okay, no problem. Maybe there are interesting serverless solutions as well, so you don't need to use containers and worry about that side of management. Lock-in problem, not a problem. And then I had this very poignant, lessons learned from a talk that Tim Bray did a few years at reInvent, and I had my own lessons. But basically, look, it's an exciting new world. Serverless is a lot of fun. Experiment, build. Tell us what you've learned. Thank you again. That's it. And now, I would love to introduce the second speaker of our session,